Okay, for number one, all it says is find the inverse of the relation. And remember on inverses, if the given function is x and then y, the inverse is y and then x. You literally just switch the places. So for this one, I still need my answer to be in braces. And then 5 negative 8 becomes negative 8, 5. And then this one becomes 14. Oops, I have to put that in blue. Instead of 14, 9, it's going to be 9, 14. And then, need another color. This one here is going to be, instead of 7, negative 1, it's negative 1, 7. And it's just that easy. All right, that's number one. All right, let's scroll to number two. Number two is pick the right graph. It says graph the equation as a solid line and then graph the inverse relation as a dashed line. So when I look at my function here, which is y equals x squared plus 1, this parabola, this is a smiley face parabola, and the original function is supposed to be graph the equation as a solid line. So I know it's a smiley face, so this one's going sideways, these two solid lines, so it can't be B and it can't be D. All right, and then it's an x squared plus 1. So when x is 0, 0 squared plus 1 is 1. It's going to cross the y-axis at 0, 1. And that's also going to be the vertex. And of these two, this one's crossing the y-axis here. That's actually 0, negative 1. This one right here is 0, positive 1. So it's got to be C. And then, of course, the inverse would be when you reverse the x's and y's. So you'd have x equals y squared plus 1. And that's simply going to be a sideways parabola. And you can see that this one goes through 1, 0 right there. So, you know, because I have to be consistent with my colors here, here's the solid one right there. Boop. So it's C. Hope that makes sense. Let's see. 3 says use the horizontal line test. The horizontal line test says if you can draw a horizontal line through your graph, okay, pretend that was horizontal, and it can cross the graph more than one time, it is not 1 to 1. So this is not 1 to 1 because it's crossing it in 3 places. Remember, 1 to 1 means every single x maps to only one y. And on this one, I've got 3 different x's going to the same y. So it's not a function. 4 says, find the inverse function, use proper inverse notation in your final answer. Okay. First things first, you're going to take out the f of x and put in a y. That's step 1, just to make this easier. Then you're going to put x where the y is and y where the x is. I'm just going to switch places. Then you're going to solve this for y. And because I've got a fraction in here, I'm going to multiply both sides by a 2 to clear out that fraction. So I'm going to have 2x on the left. And then when you take this 2 times the 1/2 y, you're just left with a 1y. But then I got to take 2 times 1, and that is 2. And then I'm going to subtract the 2 from both sides so that I'll have a 2x minus 2 is equal to y. which is the same thing as y equals 2x minus 2. And then when I said use proper inverse notation in your answer, that simply means take the y back out and put f negative 1 of x. And if you check the handwritten answer key and the answer key that came with this when I handed it to you in class, it shows of f negative 1 of x. Okay, and I got time to do number 5. 5 says, find the inverse of the given function using proper inverse notation, and then find the domain and the range of the inverse. Now this one's a trick question because the original function is a square root. It's the square root of x minus 4. Now I'm going to start with the fact that I'm asking you to find the inverse of the given function using proper inverse notation. All right. So I start by putting y where f of x is. That's step 1. Step 2 is change y to x and x to y. And then you're going to solve this for y. It's a radical, so I am going to square both sides. So when I square both sides, I'm going to get an x squared equals, the square cancels out the square root, but you're left with y minus 4. And then I'm going to add 4 to both sides. So that cancels. I get x squared plus 4 is equal to y, which is the same thing as y equals x squared plus 4. And then that's going to be f negative 1 of x equals x squared plus 4. So that is the answer to that first question, which was find the inverse of the given function using proper inverse notation. And then find the domain and the range of the inverse. Now, when I first look at this and I'm thinking, hey, this is a smiley face parabola. 1, 2, 3, 4. It only has an x squared and a constant. There is no x in it. So this is one of those that just gets transposed, and it's transposed up 4, so it looks like this. However, we only want the inverse of the original function. Now here's the fun part. The original function was y equals the square root of x minus 4. And I don't know if you remember this or not going back, but 1, 2, 3, 4, let's see. It's the square root of x minus 4, 1, 2, 3, 4. So, remember that, I don't have room here. If you have just y equals the square root of x, it starts right here at 0 and goes like that. But we've got y equals the square root of x minus 4, so it's going to move 4 to the right. I'll do this one in blue because that's the original function. So it's going to go to here and go like that. So we're looking at the inverse of that, which would be, let me draw my imaginary dotted line down the middle here. Doot, 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 doot. Remember, this is going to flip over that line, and so I'm really only looking at this part of the graph when it flips. It's going to be up here at 4, and it's going to be looking like that. And so you can see they're inverses. The blue and the purple are inverses of each other. So we are not considering any of this in the domain or the range. So my domain, I'll just put D for domain. The domain is all the x's, and all the x's on this part of the graph go from 0, which is right here, that's x, and they go this way. So, and it is a solid dot, so I'm going to include 0 to infinity. Now the range, R for range, the range on this, let's go with a different color. How about the green? The range starts right here and goes up. It goes up